Hello, today we'll continue from last time to talk about thread management. Last time we've talked about that a thread should be either joined or detached only once. Now what about a thread is neither joined nor detached? If a thread object, in this case T1, is destroyed before the thread is joined or detached, then your program will terminate. So you have to make a decision whether you want to join the thread or detach the thread before T1 goes out of scope. Let's say I want to join the thread. And in the main thread, after it creates the T1 thread and before joining with T1, it must do some work, otherwise we are not getting any benefit of threading. Say the main thread start counting. Integer I equal to 0, I less than 100, and I plus plus, C out from main I. Now pretend this is not a main function, it's just a regular function inside a deeper calling stack. And while the parent thread is doing its work, it throws an exception. Then again, the thread object T1 will be destroyed before it is joined. So we need to wrap up the parent thread's work with a try-catch block. Try catch will catch any exception that will be thrown and then do T1 join, and then you rethrow the exception hoping somebody else will catch it and handle it. So this will make sure T1 will be joined with or without exception. An alternative approach is using resource acquisition is initialization approach. We can create a wrapper class that wraps around T1, and in the destructor of the wrapper class we'll call the T1.join. So whenever W goes out of scope, it will automatically join the thread. A thread object can be constructed not only with a regular function like function 1, but also with any callable object such as functor or lambda function. Now suppose we have a lambda function, we have a functor, and let's define a functor's operator parent. And this functor will also do a counting equal to 0, I bigger than negative 100, so it counts downwards. I minus minus, say out from T1 and in the main function we can create a functor fct and then create T1 with fct functor. And now if we run the program, so both main thread and the T1 thread prints out numbers into the standard out, and it creates a gigantic mess on the standard out. Some people may say, I want to save a line of code. Instead of creating the functor then pass it to the thread, I'll just create the functor on the fly. This will not work as you expected. As you see, it won't even compile. What we have done over here is not creating a thread of T1. Instead, we are declaring a function with the function name T1, and this function takes a single parameter which is a pointer to another function and this function takes no parameter and returns a functor. And the function T1 returns a thread. This is known as the most vexing syntax in C++, because the C++ standard says whenever a statement can be interpreted as a function declaration, it will be treated as function declaration. And the solution is to add another pair of parentheses to make it explicitly that this is constructing a functor and pass it as parameter to the constructor of T1. So far, our threads has been function or functors that takes no parameter. Now let's say I want to pass a parameter to the thread. Say this functor takes a parameter of string msg, and in the functor it prints out T1 says msg. And let's remove these things and create a string s equal to where there is no trust, there is no love. And the way to pass the string s to the thread is take s as the additional parameter of the thread's constructor. And let's say in the main thread I also print out the message s. So if I run the program, it makes a mess, but you can still figure out that both T1 and main thread are printing the same message. Now, since the parameter is a string, I want to pass it over by reference instead of by value, so I can save a lot of copying. So I changed the functor parameter to be passing by reference. Believe it or not, even now the string s will be passed over to the thread by value instead of by reference, because a parameter to a thread is always passed by value. To prove that, let's say in the thread I change the message to trust is the mother of deceit. And I first want to make sure that T1 has finished its job by calling the join function, and then delete all this, and then print out the s. Now let's run the program. So as you see, the message trust is the mother of deceit is not printed out to the screen. If you really want to pass the string by reference to the thread, you have to use standard ref. This creates a reference wrapper for s. And now let's run the program again. As you see, trust is the mother of deceit is printed out by main. So now we have created a situation where the child thread and the parent thread are sharing the same memory, which is the string s. Another way to achieve the same thing is, instead of passing s over by reference, we can pass it over by good old pointer. Now suppose s is no longer used in the main thread, and I don't want to share the memory between the threads, because memory sharing creates data race problem, which we'll talk about in the future. And I don't like to pass s to the thread by value either, because passing by value is inefficient. Then there's another way I can pass the parameter, which is using the move function. This will move the s from the main thread to the child thread. This is both safe and efficient. In C++ library, there are many things that can only be moved and cannot be copied. As a matter of fact, the thread object itself can only be moved. So if I create another thread, T2 and equal to T1, and this will not compile because thread cannot be copied. So if I really want to transfer the ownership of a thread from T1 to T2, and I have to again use the move function. And now I have to call T2 join because T1 is empty now. Each thread has an identification number associated with it. To print out that number, I can do this thread get ID. This will print out the parent thread's ID. To print out the child thread's ID, I can do T1.getID. Or I can do this thread get ID inside the child thread. Now let's consider this question. Say I have a very complicated problem to solve. And how many threads should I create to solve that problem? Ideally, I should create as many number of threads as the number of cores that I have. I don't want to run more threads than my hardware can support. That is called oversubscription. Oversubscription is bad because when there are more threads running than available CPU cores, it creates a lot of context switching. And too many of context switching will degrade my performance. C++ library provides a function called hardware concurrency. This will give me an indication of how many threads can be truly running concurrently for my program. For example, it might give me the number of CPU cores. So this can be a useful guide for splitting tasks among the threads. That's all for today. Next time we'll start talking about data race and synchronization. Feel free to subscribe to my channel and check out the other videos I have. Bye bye.